Recording in progress.
Okay, as we expected, you are going to open the camera. I would like to allow more interaction between you and me. Okay, as said before, you are going to open the camera. Hi. All right, please open the camera and let me know you are here. And I would like to have a more interaction between you and me. And starting from today, you know that in February we would have we still have a Zoom lesson until 21st of February. So we don't know whether or not the face-to-face lesson will consume. I would like to meet you guys or here on Zoom. Now, please make sure all of you have got this. Don't just laugh. Okay, why you just laugh? I don't know why you laugh. Now, how about the others? Okay, don't be afraid. Just have your camera on and let me know you are here. And I found some of you just don't tell me that you just sit on your bed and listen. You better find a place to sit properly and start over the lesson. 河本正林懷軒陳宇楊仲義 You have a camera with you?
Wait. Let me set up my camera.
Yes. You have to find some time, jump out of the bed and you just turn on the camera. Here. Why your camera is so blurry? I cannot see it. Yes, nice. 河本林懷軒會係林曉峰河本正。Oh, I see you. Oh, Lâm Hải Hiên, you have got another guy with you. I don't know. You're having your brother. You attend the lesson together. I see. Now, so let's start our lesson. You will see our the book, page 15, on acid and alkalis. Now, any questions so far? Last time we talked about acids, right? Now, acids, what are they? What are the properties? And you know that water plays a very important role, right, in order to exhibit acidic property. So whenever you talk about acid, you would heard of the term hydrogen ion. Okay, hydrogen ions. Now about base and alkali. We would use, remember the graph. So you will have this one base and alkali here, right? So what does it tell? It tells you that most oxide and metals, they are bases, and you give you a relationship between a base and an alkaline. Alkaline is a base, but not all bases are alkaline. Can you get my point? So if you want to say sodium hydroxide, for example, sodium hydroxide is a base and also is an alkaline. Can you get my point? But for copper 2 oxide, it is a base but not an alkaline. Now the point of classifying them, which is that one of them is water soluble. Okay, all of you please mark it down. Water soluble. While bases, it's just a very general term to tell you a substance which just react with acid to form salt and water only. So it doesn't tell you anything about the solubility. So can you get my point? So that whenever you talk about the word alkaline, it can also be said as a base, but it is highly water soluble. So we call that an alkaline. Do you understand? So once you will see those table, and you may find then we have got quite a lot of chemical, we will call that an alkaline or the base. So namely, can you see the pattern? How about this? Copper 2 oxide, magnesium oxide, Nag2 oxide, iron 3 hydroxide. And for soluble base, you may find sodium hydroxide, potassium hydroxide, calcium hydroxide, and ammonia. How about some strange chemical, right? For example, calcium oxide. What would we say about calcium oxide? Is it an insoluble base or soluble base? So what do you think? If I say that is calcium oxide, can I say it is an insoluble base or soluble base?
Insoluble.
Insoluble. Calcium oxide.
Yeah,
Calcium oxide. So what will happen if I have calcium oxide meets water? Do you have any reaction? Now we call your memory about calcium oxide, we call it quicklime. And we added water to form calcium hydroxide. So indeed there is a reaction. So in this case is very special, right? Calcium oxide react with water to form calcium hydroxide. Indeed, it's not just calcium oxide being so special. For all, I can say it's just a group 2 oxide, right? MgO doesn't dissolve in water, but CaO it dissolves in water. Instead, there is a chemical reaction. And a similar case that will be found on all other group 1 oxides. So they would have a reaction between oxide and water to form an alkaline hydroxide. Okay, so I leave you guys to be highly aware of what is meant by most oxides and hydroxides, they are a base. Okay, you get my point? So in which some of them is said to be reactive in water to form a hydroxide solution as well. Can you get my point? So oxide, we have got group 2, mainly for group 2, transition metal oxide, group 3 oxide, all those they are water insoluble. How about for group 1? Group 1 oxide is water soluble. But instead, it will react with water to form hydroxide. And group 2, if we will talk about group 2, how about group 2? Calcium oxide, right? It's a very special case. Indeed, it's not calcium oxide, but also the one next to it. Strontium oxide, barium oxide is also reacts with water. All of you, please mark it down. Strontium oxide, barium oxide also will behave very similarly. How about hydroxide? Another case. Take a look on hydroxide. What happened to hydroxide? Group 1, hydroxide, or water soluble. Group 2, hydroxide. What happens to this? Group 2 hydroxides. Mg hydroxide, no. Calcium hydroxide, slightly soluble. So that's why we have got lime water. What else? Barium hydroxide. This is water soluble. Very strange, right? The solubility of group 2 hydroxide increases down the group. Group 3 hydroxide. Or water insoluble. So as the transition metal hydroxide, they are water insoluble. Now, so I do hope that by doing so, you will get to know more about the classification of oxide and hydroxide when you talk about it as a base or alkali. I said before, for how about oxides, right? Group 1 oxide. So what will happen? I said before, react with water to form hydroxide. So that is a reaction. So group 2, very similar. MgO, no. Calcium oxide, we have a reaction. And strontium oxide, barium oxide, also reaction. While the reaction agrees with this, okay? So they will form hydroxide. Transition metal, group 3, oxide. So what will happen? Water insoluble. So generally speaking, Mr. G, you know that whenever you talk about group 1 salts, it is water soluble. Yes, that's right. Okay, all group 1 salts, they are water soluble. So that's why we call it as an alkaline. Do you understand? Questions?
淺Sir.
Yes.
我想問你睇 Group 2 hydroxide 同埋 oxide 嗰陣時，點解就一直都冇講 radium 嘅
？Group 2， you mean Group 2？
係。
Group 2， can you say the question again？
即係提緊 Group 2 hydroxide 或者 oxide 嗰陣時，一直都冇提到 radium，淨睇到 strontium 同 beryllium。
Barium also okay. Now you take a look on the periodic table. Okay, periodic table. For those chemicals which are quite far below group 2, okay, so it is said to be radioactive. So whenever you talk about the word radioactive, and there may be some other changes, what we call it as radioactive decay. So it's out of our consideration when you talk about chemical reactions. So theoretically, also they will have such a phenomenon, but it is in practical sense, they would first of all decay to form some other chemicals before we said they are said to be water soluble or not. In other words, it's not so stable in nature. Can you get my point? So we would focus on the periodic table on top to below. Of course, if you want to talk about beryllium, you mean beryllium, is it? Be or barium? This one. This one, is it? Beryllium, is it? The one below, or the one on the topmost.
In group 2, barium.
Barium also. Okay. So beryllium, lithium is group 1. Beryllium, boron, carbon, silicon, all those they are period 2. Very special case, in which they will have some very special chemical property when you compare with the others. So we'll seldom talk about pure 2, okay? But for usually we will talk about magnesium downward. Okay, so you don't worry too much. We just leave this one later for later discussion for periodic pattern. You understand? Very special for barium, but we will not tell this one. So there must be some reason behind. So what is mean by alkali? Alkali is that it is a chemical which will release hydroxide ion when dissolved in water. Wow. Again. Now, a very authentic example. So you may find the 2 cases. The first one, when you talk about oxide, once it dissolves in water, and they would form immobile. They will turn immobile ions to turn it mobile. Okay. So that's why somebody would say that this one, you talk about sodium oxide dissociate. Okay, so we call this a process dissociation 理解. So the chemical in which it will make the ions kept in a fixed position and make it free moving. Now, how about ammonia? Ammonia is somewhat very special. Now, so you will take this one. Now, we call your memory about dative covalent bond again. So you've got ammonia. For hydrogen, for nitrogen, it is we have got lone pair electrons, right? So they would react. There is a interaction between this and water this time. So it seems like this, okay? So they would form a compound. The first one is ammonium ion. The other one is hydroxide ion. So the process of turning molecules to form ion, we call that ionization. Okay, we call it ionization. So you may see that too. The 2 process is a little bit different. Now, when you talk about, when you compare this with acid and alkali, for acids or are said to be covalent compound. So once it dissolves in water, they would ionize. So they would react with water to form hydrogen ions. But for alkali, we have got 2 cases because most of the alkaline, they are said to be the metal hydroxide. So once I dissolve in water, I simply split that ions to make it free move. So we call that dissociation. But the very special case is on ammonia. Ammonia, you know, that is also a type of alkali, but it's a molecule. Once it get mixed with water, there is ionization to form ammonium ion and hydroxide ion. So this one is the only case where you talk about it as ionization. Now, because it does not totally react with this, so it is just a slight ionization, very slight ionization in water. So you will see the arrow having this. It is a reversible sign. Okay, reversible sign. So that's why we will call ammonia a weak alkaline, because not all 100%, slight, which means not 100%, ionized to form ammonium ion and hydroxide. So we will see that only small amounts of hydroxide ions they are formed. So when you talk about the chemistry about these 2 types of alkaline, sodium hydroxide and ammonia, you will say that sodium hydroxide will cause more chemical burn to you. Now, while you talk about the same molarity and I drop into hand, you cause chemical burns, for example, sodium hydroxide is more corrosive when you compare with ammonia of the same concentration. Any questions so far? You understand? Understand or not? I'm again just thinking. Do you understand? Do you understand? Okay. How about Sư Đồ you understand what I just said?
Yes.
Okay. 好靚仔㗎嘛 Okay. Lâm Hiểu Phương, you understand?
Yes.
Okay, thank you. So, any questions so far? So of course we would similar to acid. We will talk about the common ion. This time alkaline, you talk about hydroxide. It's our common ion. So whenever you talk about the reaction of alkaline, we focus on OH minus. We focus on OH minus. Okay. Questions? Any questions so far? So, now you may see the next page on this aqueous ammonia. Now, ammonia is a very special chemical in which this is a gas in nature, right? Ammonia gas is a gas in nature, while it is said to be highly water soluble. All of you, please mark it down. Highly water soluble. Because of that, in order to produce aqueous ammonia, which means ammonia solution, you are going to bubble the lime water into water, like this setup. So what is the difference between this setup and the normal setup, right? Normally we would produce the aqueous solution by simply bubble the gas like this, right? So what is the difference between these two? So what is the use of using inverter funnel? Do you understand? We have got that too, right? So what is the difference between this setup and this setup? Do you know, Matthew? We have got that too. The one on the left hand side and the one on the right hand side. So what is the difference?
係咪因為 bubbling 嘅話，驚佢會有個水 escape 出嚟，但係 inverted funnel 就可以 trap 住佢哋。
Because of what? The water will trap? Can you elaborate more?
Inverted funnel 會 trap 嗰啲NH3，但係如果 bubble 嘅話就驚有個水咁樣 escape 出嚟。
You mean the water? You mean the gas will come out, will leave easily.
Yes.
While this one, the ammonia will still inside. There's one concept, one idea. Agree? All of you agree? Zhao Zheng, what do you think?
Agree.
Agree. So it's used to trap the gas.
應該係啦。
Okay. Any opposition to this statement? Zhendong, what do you think?
I think the answer already written in the book.
Yeah,
which is increase the area. Yeah, increase the area over which gases can be dissolved and prevent stacking back.
So, what is the difference between that two setup actually? Now, I would like to show you one very authentic, very typical experiment. Is for you, especially for those people who are planning for Info Day next year. You will get this. We will call that fountain experiment. A very very authentic experiment on that. So take a look. Please take a look.
The flask is filled with highly soluble alkaline ammonia gas. It dissolves in water, causing a reduction in pressure that draws more water into the flask. The demonstration is tricky, but the result worthwhile. The fountain takes place in this apparatus, a 2 decimetre cubed flask fitted with a bung, with a piece of glass tubing with a jet at one end, similar to the end of a pipette, and a syringe attached to a short length of flexible tubing. The tip of the jet should end up about 2/3 of the way up the flask. This flask, and indeed all the other apparatus, must be absolutely dry. If necessary, rinse it with propanone and allow it to evaporate. The ammonia is generated in this apparatus. 880 ammonia is heated in here with a couple of boiling stones. As it passes through here, there's some potassium hydroxide in there which will dry it, passes through here and is collected by downward displacement of air because the ammonia is lighter than air. Heat the ammonia solution gently for several minutes. When you think that the flask is full, test the bottom with damp indicator paper, which will go purple, showing that the flask is full. When you're confident that the flask is full of ammonia, stopper it. The flask can now be left for some time, and you may prefer to prepare the flask of ammonia and perhaps a spare before the demonstration. Have ready a 2 decimetre cubed trough full of water and add to it some universal indicator. And you want enough to give a clearly visible colour, far more than you'd use for a titration, for example. Add to it some acid, and you want just enough to make the water turn red. Then you need a stand and a clamp or a ring to hold the ammonia. Quickly, so that no ammonia escapes, you need to remove the bung and replace it with the jet assembly. Keeping the rubber end of the tubing in the water. Squirt some water from the syringe into the flask, and this may be enough to start the fountain. If nothing happens immediately, then swirl the flask, keeping the rubber end of the tubing in the water. As the water emerges, it turns from red to purple due to the alkaline nature of the ammonia. The fountain will continue for some time until all the ammonia in the flask has been displaced by water. Should the fountain fail to start, the most likely reasons are either the apparatus being wet or leaks in the apparatus. This apparatus does have a small leak, but it has still worked, but it is probably the reason why this hasn't gone through to completion. You may find a competent assistant helpful in manoeuvring the flask, and you may need to practice it a few times before you become confident. Preparing the ammonia flask beforehand with one or more spares may help on the first few occasions.
Okay, have you all read that? So if you want to watch it again, you may type ammonia fountain experiments in your YouTube, and you may see that. So what is the conclusion? What is the conclusion? Now, what will happen if I do that do the experiment again, right? You have got that actually the whole case is simplified by having this, right? You have got the gas full of ammonia while it is trapped inside. So once I put it into water, what will happen? So the water, because ammonia is highly water soluble, so what will happen? It will dissolve in water. So we will produce a reduced pressure. So what will happen? And it will drive those water up and make it as a fountain, because this one is highly water soluble. So that type of effect, increasing in the level of water, is very, very fast. It seems like a fountain, okay? It seems like fountain. So we call a very typical example, we call it as a fountain experiment. Fountain okay? So this is the case. What will happen if I change ammonia to some other gases, just like nitrogen, hydrogen? So of course there will be no fountain. Okay, why? Because those two gases, they are water insoluble. Okay, you get my point. So this is what you know about this experiment. So go back to this. The purpose of adding an inverter funnel here is to what? Is to allow a very big area of meeting of the gas and water. Can you see that? This area is a place where the ammonia start to dissolve with water. So in case this one, it will allow a more surface of area contact such that they will dissolve it much. But it's not just here which serve a purpose, but also here. Can you see that? A bigger area, a bigger volume inside. It will make a slight increase in the in the height of the water level. Can you get my point? Do you understand? So by doing so, if I have a larger filter funnel, for example, of course, the increase in the water level will become smaller. Can you get my point? When you compare with just a hollow, narrow tube of the delivery tube. So, can you get my point? At one time, you are going to dissolve, for example, 10 ml of the gas, which will make a increase in the level of water level. So it will increase smaller to the smaller extent. But if you talk about 10 ml of the gases all dissolved, it will rise us up to this level. Can you get my point? So that's why we call it is to prevent the sucking back of the water. Do you understand? Do you understand? Anyone who don't understand, could you please let me know now? You understand? So go back to this. In order to give you a better visual effect, something has been added. What is added? What has been added to this fountain experiment? A producer for visual effect. Hello, 何小王, where are you?
喺度。
問緊你嘢。What has been added? Yeah. What has been added?
唔知喎，真係。
唔知。頭先加咗啲嘢落去喎。
Ammonia.
In order to have better visual effect, okay, now you realize I added something to have a better visual effect. It has been colored.
Universal indicator.
Yes, universal indicator. So what will happen? Originally, it is green here, right? But later on, I added to red inside because I have added exit. Okay, so why I add this into here? Of course, this one is red originally. But later on, once it forms a fountain and drop in the top, what will happen to the color here of the water? It will be becoming purple. So why? Why?
Alkali.
Yes, it's an alkaline solution now. Why? The acid reacts with ammonia, quite a large amount of ammonia to cause neutralization reaction, but the ammonia is still a lot. Okay, so which is overwhelming the amount of acid just with the water. So of course, on top of that is purple. Do you understand? Do you understand? Okay, so this is what you talk about ammonia, very special. And what is the use of the alkaline and bases in our daily life? Again, we seldom use alkaline in our daily life, isn't it? Actually not. Any people who have stomachache very easily, very often. Now you may need to take some anti-acid tablet. Now there are two types of anti-acid tablet. One of them I take in order to inhibit the secretion of stomach acid. Right? So it is always go with some other medicine to reduce inflammation, right? Or some you have something infected, the doctor will give you two tablets, right? One is to reduce fever or reduce the symptom flu, and later on they will give you another symptom. They tell you it's virus, right? So is that tablet is quite different from this. Okay. While the one is usually given by doctor is a very small, tiny tablet. It is used to inhibit the secretion of gastric juice. How about this? Is another one. What are they? It is in larger tablet. Okay. So what? Once the doctor give you, or you just buy it on the market, but you can buy it, right? So what should you do to this anti-acid tablet? Just remember, very often they ask you to chew before you swallow. Chew. You break it into pieces. Do you understand? So it is another principle. It's another principle is to what?
Increase the surface area.
Yes, increase the surface area for the reaction to occur. Yes, that's right. So could you please show me the chemical equation involved? Now, this is what we usually do in chemistry quiz or exam. 你知唔知道胃藥有兩種啊？ You know it? Okay, one of them is to inhibit the secretion of the gastric juice inside the stomach. The other one, this one is not used to stop this release of gastric juice. Is that gastric juice is already inside? Okay, but once I eat it and let the acid react with the chemical inside, so we will call this an active ingredient, 有效成分. Whenever you buy the drug, remember to take a look on the ingredient. They will tell you what is set as an active ingredient. Now, not all tablet is useful to you actually. Only part of them is useful. So we call the part of them that those chemicals they are said to be active ingredient. Do you understand? So what is the chemistry? Lê Kinh Hồ, do you study biology? Do you study biology?
Yes.
Tell me the chemistry involved. It will react with gastric juice. So what is the chemical name of gastric juice? What is the chemical found inside gastric juice?
Enzyme.
Besides enzyme, what makes it acid? What makes the grassic juice acidic? Chen Yu,
I forgot.
you forgot. Okay, Chen Yu, do you know?
What? Enzyme.
Besides enzyme. Why
Hydrochloric acid.
Yes, that's right. So it is hydrochloric acid. Besides enzyme, we have got mainly hydrochloric acid, which make the grassic juice acidic. So what will happen? So they will react, right? Could you please write down the equations on your book? What will be formed? What will be formed?
Water and aluminum chloride.
Yes, water and aluminium chloride. Aluminium chloride, so AlCl3 for that, and water. So you are going to balance the equation. Okay, you're going to balance the equation. So this is 3, and this one is MgCl2. Okay, and put a 2 here. We will together with how many water is 2H2O. Do you find it? Do you find any pattern? Whenever you talk about this one is 2, is 3. Here comes the water being 2 and 3 respectively. Now this is the one of the way which will help you balance the equation easily. Do you see that? Of course, you may also seek for the pattern. If you want to talk about the concept of ionic equation, so you may find the number of water to be formed. You have to check against the chemical combination of hydrogen ions and hydroxide ion. So you may find that magnesium, hydroxide magnesium is 2+ charge. Our hydroxide, we have got 1:2 ratio. So HCl is just monobasic. Of course, you put it as a 2, and altogether they will form 2 water. Okay, get my point. Similarly, for aluminium hydroxide, we have got 3 hydroxide per 1 formula unit of aluminium hydroxide. So we have got monobasic acid HCl, we got it times 3, such that we have got 3 H2O. You understand? Do you understand the pattern? You get to know this. So this is how we usually do it. So it is just a remedial issues. 有冇屋企人係有呢個問題㗎？ It's just a remedial issues. For example, we have got some burns inside the stomach. Okay, because of nothing. Of course, it is something happening inside because too much grassic acid found inside stomach, which will cause you uncomfortable. So, eating the antacid tablet would help. Now, could you please see the word antacid? Now, indeed, it comes from the word anti-acid, 抗酸劑, but because of the vowel, 響音, I and A that comes before and next, okay? So it is quite difficult to pronounce. So we would change the word to antacid. It's something about English. Any questions so far for that?冇嘛？亦都有人咧 in the past people would try to deal with the too much grassic juice inside stomach by drinking lime water。以前都有人聽過嘅，即係飲石灰水。Or you would heard of one chemical, we call that milk of magnesia. Have you ever heard of this term? Milk of magnesia. You go to the web and search milk of magnesia. Have you ever searched on that? What is that? It is a bottle of fluid, liquid-like substance. Once I pour it, it's not a pure liquid. It's a milk-like chemical, and you are going to drink it. Of course, why is it milk? Milk-like. you are drinking something powdery, not water soluble together with water. So somebody will not think drinking it comfortable. Because you are just drinking something watery but with some powder. 有冇人飲過呢啲咩美奶片嗰啲嘢㗎？美奶啊 ，milk of magnesia。咁飲起上嚟個質感咧就好難飲嘅，知唔知點解啊？話就話牛奶啊嘛，牛奶飲落去滑㗎嘛。But for this, what will happen? Some powdery feeling in your mouth。飲完之後咧，嗰條脷鞋地嘅 ，is because we have got some powder inside. You understand? Okay. So, any questions so far? 幾有趣啊 ！Now take a look on the other one. Yes. Okay. So take a look on the other one. For some instance, people would also add something to the soil to reduce acidity of soil. You know that soil cannot, the plants cannot grow well in acidic soil. So you are going to sprinkle some important chemical, just like calcium hydroxide, into the soil to reduce acidity. 熟石灰 Do you still remember? Lime, quick slick lime, okay? So you are going to add slick lime to the soil. Of course, somebody would also put quick lime. But be careful, if you use quick lime, if I put it in the soil, the plants cannot, must be free from the soil. Do you know why? I can also sprinkle calcium oxide into the soil for farming, but never with the plants there. Why? Once it meets water, what will happen? Okay? 所以咧有兩種方法嘅，第一係咩啊？熟石灰咧就咁滲落去啲泥土度得啦。第二個係咩啊？你要用生石灰，但係攞生石灰放落啲泥度會點㗎？會放好多熱㗎，得唔得？咁所以咧有陣時你見到啲人農地種嘢有兩種方法嘅，即係有一種咧就種緊啲嘢落，你咪滲熟石灰咪冇事咯，啲植物都幾好啲㗎，因為唔係好溶嘅水嘛。So it is a slow release. Slow release type of a acidity regulator, but for this one is a very quick action. So the soil must be free from the agricultural plants. Do you understand? 3. Ammonia. Ammonia in window cleanser, glass cleanser. Why? Okay, it will help. Wetting, it is act as a wetting agent. Wetting agent. So what does it mean by wetting agent? So the window is here. We have got a water droplet, so easy, right? So once I spray into the window cleanser, I wipe it. What will happen to this? The water droplet, once I was just spray here, will then spread like this, okay? So we will call that wetting. Okay, so we call that phenomenon wetting. So whenever I have got that window cleanser wipe onto the window, it is a very good anti-fogging agent. Okay, anti-fogging agent. 防瑕防霧啊。So you will find this one especially useful in the common day. In these days while you are going to clean your home with your dad and mom, right? So you better have some glass cleanser, window cleanser, and this one you may have got drainage cleaner, especially sodium hydroxide. So it is used to dissolve the oil. But of course, it is somewhat in layman term. In the reality, you are going to react or hydrolyze 水解啊，水解 to hydrolyze the oil. Okay, to hydrolyze the oil such that the oil can go with water together. Okay, or you may use this one or caustic soda. Caustic soda, red bottle, red bubble cap with white, okay, with some powder inside. They will sell you $10 for 3 bottles. You go to Ngam and you can buy this. It is also help clear the blockage of the oil from the sewage pipe. So you know that you usually use it in your kitchen sewage pipe, right? But of course, this may make the water pipe change its shape so easily. Why? Again, caustic soda mix water, so gives out heat. So handle this with care. Don't tell your dad and mom that I now understand chemistry and let me do that way without taking care of the safety precautions.
跟住又要揾人嚟收啦。
you know it. You can never be the one to tell your dad and mom that you know chemistry well and let you handle. Be aware of the safety. You understand?
Understand.
跟住個渠穿咗。
你知唔知發生咩事喺呢度？明啊？啲鹼嘅用途係咪好多？So in short, one of them for your body to treat stomachache. 2 is what? For in agriculture, for what? Reducing the acidity of the soil. And 3, for cleaning. Either it is an anti-fouling agent or you clear the oil blockage. Do you understand? So this is the uses of alkaline and bases. What is the characteristics of dilute solution of alkali? So they are very commonly found in your lab. Okay, potassium hydroxide, KOH, NaOH, lime water, and aqueous ammonia. Now you take a look on the hazard warning label. You may find that you usually call it as irritant or even corrosive. But that corrosive is quite different from acid. Now, if you have some touch of acid onto your finger, anyone who have such an experience, 有人試過掂咗啲酸啊落隻手度 so what will happen? Some burn, right? Some hot feeling, some itchy feeling, right? So what you need to do, if you send something like this, you need to wash your finger or hands thoroughly with running water. But for alkali, it's very special. For alkali, for example, sodium hydroxide KOH, once you dip it on your finger, okay, you don't have much feeling. But all of a sudden, while you are asked to wash your hands, all of a sudden you may find a very slippery feeling. And it seems that your fingerprint has been blurred. Why? The alkaline will start dissolve your fingertip without any feeling. So that is problematic. So remember, it's slippery. And have you ever tasted something alkaline? Slippery feel. And 2, 滑手嘅線嘅，滑潺潺嘅。And also, if you can, of course, lime water can be drunken, but very nasty. The smell is bitter. Have you ever tried eating some wonton noodle? In case you know that the making of wonton noodle, I add some 鹼水, right? Remember that 鹼水 is not fine 鹼水. You know what? That GAN is different from that GAN. It is usually get mixed with sodium hydrogen carbonate solution. Okay, so it is from or potassium hydrogen carbonate. So if once you taste that solution, is a very strange feeling. Okay, a little bit bitter. So it is a bitter feel. Dilute solution of alkaline is electrically conductive. It reacts with solution containing certain metal ion to form precipitate. It will react with ammonium compound. Okay, so these two you may find it problematic. You may not know it so easily. Okay, so I would like to share with you on this activity and to summarize what is happening in the following pages. Okay, 14.3. Oops. How? Why? How come? I better click it. How many time? How much time will be left? 4 minutes, is it? Is it 4 minutes? 做幾耐？哦，仲有啊，咁講埋呢個先。如果唔係我就唔同講法，講呢個先。
In this experiment, you are going to investigate the effect of dilute solutions of alkalis on indicators, reaction of dilute solutions of alkalis with metal ions, and reaction of ammonium compound with calcium hydroxide. Pour 4 cubic centimeters of dilute sodium hydroxide solution into each of 3 test tubes. Add 2 drops of litmus solution methyl orange and phenolphthalein to each test tube separately. Record your observations. Litmus solution in dilute sodium hydroxide solution appears as blue. Methyl orange in dilute sodium hydroxide solution appears as yellow. Phenolphthalein in dilute sodium hydroxide solution appears as red. Pour 4 cubic centimeters of dilute aqueous ammonia into each of 3 test tubes. Add 2 drops of litmus solution, methyl orange and phenolphthalein to each test tube separately. Record your observations. Litmus solution in dilute aqueous ammonia appears as blue. Methyl orange in dilute aqueous ammonia appears as yellow. Phenolphthalein in dilute aqueous ammonia appears as red. Pour 2 cubic centimeters of aluminium ion solution, calcium ion solution, lead 2 ion solution, magnesium ion solution, iron 2 ion solution, iron 3 ion solution, copper 2 ion solution, and zinc ion solution into 8 test tubes separately. Add a few drops of dilute sodium hydroxide solution to the aluminium ion solution. Shake the mixture. Continue adding sodium hydroxide solution until no further observable changes. Repeat the above process by using the other 7 metal ion solutions. Record your observations. In the observations, white precipitate formed in aluminium ion solution. The precipitate dissolves in excess dilute sodium hydroxide solution. White precipitate formed in calcium ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. White precipitate formed in lead 2 ion solution. The precipitate dissolves in excess dilute sodium hydroxide solution. White precipitate formed in magnesium ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. Green precipitate formed in iron 2 ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. Reddish-brown precipitate formed in iron 3 ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. Blue precipitate formed in copper 2 ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. White precipitate formed in zinc ion solution. The precipitate dissolves in excess dilute sodium hydroxide solution. Replace dilute sodium hydroxide solution by dilute aqueous ammonia and repeat the experiment. Record your observations. In the observations, white precipitate formed in aluminium ion solution. The precipitate does not dissolve in excess dilute aqueous ammonia. No precipitate formed in calcium ion solution. White precipitate formed in lead 2 ion solution. The precipitate does not dissolve in excess dilute aqueous ammonia. White precipitate formed in magnesium ion solution. The precipitate does not dissolve in excess dilute aqueous ammonia. Green precipitate formed in iron 2 ion solution. The precipitate does not dissolve in excess dilute aqueous ammonia. Reddish-brown precipitate formed in iron 3 ion solution. The precipitate does not dissolve in excess dilute aqueous ammonia. Blue precipitate formed in copper 2 ion solution. The precipitate dissolves in excess dilute aqueous ammonia. White precipitate formed in zinc ion solution. The precipitate dissolves in excess dilute aqueous ammonia. Put 1 spatula measure of solid ammonium chloride and 2 spatula measures of solid calcium hydroxide in a mortar. Mix the solids well by using a pestle. Put the mixture into a test tube. Warm the mixture gently. Hold a piece of moist red litmus paper in a stream of the gas given off. Record your observations. The moist red litmus paper becomes blue.
Okay, a quite long experiment, and but what do you find in common? What do you find in common? Now, because time is running short, I cannot explain too much about this. So, well, how much time is left? It's just 3 minutes. Okay, so first of all, I'd like to tell you the general property of alkaline by ending up the lecture today. First of all, besides steady slippery field, bitter, what else? Litmus. You still remember that chemical? Litmus, lethal orange, and phenolphthalein. There is a color upon action of alkali. The first one is blue, methyl orange is yellow, phenolphthalein is red. Okay, or you will see it seems like magenta, a very shocking pink in highlighter color, right? Second, they are conductor of electricity. So you may find again the reason behind is that they contain mobile iron, as said before. And 3, they react with certain metal ion to form precipitate. So we have got the 2 items. You read the book very carefully. One is lithium alkali. So the other observation is I add the alkali in excess. So the observation is different. So that's why you need to memorize all those. 4, the ammonium compound can react with hydroxide under heating to form what? Salt, ammonia, and water. Now, because of that, you are going to test it by what litmus paper? Moist red litmus paper and they will turn it as blue. So this is the only gas that you study in DSE, right? Which it tells is an alkaline gas. Most of them is neutral, acidic, right? But for alkaline gas is a very, very special. Okay, well, what is the gas? It seems like you go to the toilet and you can smell such. Okay, so this is what you will know about the general concepts about these. Now spend some time on reading those, okay, by yourself, or reading those by yourself, okay, those pages, and up to this. Now and also this, and try your best. I just talk about fountain experiment already. Okay, so please spend some time after reading those. I would please check this class practice and do it. And I would like to check it after the Chinese New Year. Now, don't worry too much. I would have another video for self-help to read these pages. Okay, such that you would find life easier to you. Do you have any questions? Now, any difficult part, could you please write, put down onto your chat box and let me know, and I would like to adjust it while I deliver my YouTube video. Tell me. All right. Okay. I've seen most of the comments. Yeah. Thank you. Before you leave, I need to check your attendance. It seems 25 and then -2, which is 23, but I find it seems somebody is missing, isn't it, right? For one thing, you have got 2 devices, which means 21 only. Who is missing?
幾新鮮啊！冼俊琪，冼俊琪唔喺度。
係咯。It seems冼俊琪 is not here. Absent this morning?
佢冇，朝頭早有返。
冼俊琪 not here. I'd like to talk to him. Okay, thank you. It seems I can't see him. Okay. Then any more questions before we leave?
Mr. Chi.
Yes.
我想問下咧，啱先講胃酸嗰陣咧，咪就係話可以用量嗰個即係 aluminium hydroxide 同 magnesium hydroxide 嘅，但係我哋落到去嗰個小腸嗰度唔係有 sodium hydrogen carbonate 嘅咩？點解我哋唔可以直接用 sodium hydrogen carbonate 食落去，咁咪可以中和胃酸
？Sodium hydrogen carbonate。
係啊。
You can, but what will happen if you have got acid and sodium hydrogen carbonate react together? Of course, you can neutralize acid. So what will happen? It will give you salt, water, and what? Carbon dioxide. So what will happen if you have got too much carbon dioxide inside your stomach? Of course, your stomach will not feel so comfortable. Pressure will go up. You will have got some stomach gas. Okay, so you are going to put them out occasionally. So it is somewhat another problem. Okay, and the reason of using the aluminum hydroxide and magnesium hydroxide is first of all, it is not water soluble. So that type of action is a slow release action. Okay, slow action. Now, if you want to deal with the stomach acid, you can, why not, somebody will think it, why not drinking this? Of course you can. If you really want to deal with the too much gastric juice, but it's another issue, right? You know it. So you just go back to the careful consideration of the
咁直接飲嗰啲鹼水咪得咯。
咁都得，咪但係頭先我咪講話你唔止胃脹胃氣咁簡單啦，你要藥啦嘛，因為你如果你同 hydrogen carbon 有關嘢，你飲落去嗰個即係個胃入邊，咁個胃嘅胃酸咪同佢 react，咪會 form CO2 咯。咁所以咧，你話飲哥士的得唔得？好快添，咁但係你未去到個胃嗰陣時，你傷晒喉嚨啦，係嘛？明唔明啊？咁所以咧，我哋要揀嗰啲嘅所謂即係點樣去醫胃酸咧？最好就你唔傷其他嘅器官。sodium hydroxide 啲好傷其他器官，包括你個脷啦、嗰個喉嚨啦等等。之前有聽過有人飲哥士的落個喉嚨度，跟住就大件事啦。得唔得？咁所以咧，唔係你話諗住用邊隻用邊隻嘅，即係各有唔好嘅地方。好，做咩嘛？
點解我哋嗰個 pancreatic juice 就會用sodium hydrogen carbonate 嘅
？It's a weaker alkali. You better ask God. I don't know. I don't know. Just ask God. 係啊 ，but it's not sodium hydroxide as well. Of course. 咁點解通常係啲 hydrogen carbonate 㗎？最有可能咪係即係我哋身體入邊比較同佢有關嘢，咪 carbon dioxide 咯。係啊，我哋好少特登人去製造一啲hydroxide 都係嗰句啦，因為本身太酸或者太鹼咧，喺個身體入邊其實都係唔好。但係 hydrogen carbonate 係生產到出嚟嘅，係啊。我哋好少，我哋身體入邊唔會製造到啲 hydroxide 咁大量咯，應該咁講。OK， 有冇嘢問？冇就 you just stop it here. See you guys. I wish you guys a happy Chinese New Year. Stay healthy, stay strong. Okay, and see you guys in the year of Tiger. Bye bye.
拜拜
Happy New Year，
Happy New Year，新年快樂，
新年快樂啊！拜拜。